Claire, I'm handing over to you. The stage is yours.
Thank you. Thanks so much for inviting me. Can you all hear me okay before I go into sharing my screen? Excellent. Right, so I think the only way I've found to make this work, I'm afraid, is to do that before I go into presenter mode. Can you all see the right thing? Fantastic. All right. Well, thanks so much for inviting me here today. Yeah, it's a shame not to be able to see you all in person, but you know, I look forward to some chat and questions at the end. I'm going to be talking about designing for IoT essentially. So as hardware is hard is a thing that sort of gets bandied around very much in the IoT community. So I'd like to sort of unpack what that means in terms of UX. My background is as UX. This is going to be quite a broad talk in terms of definition of UX. It's got the sort of big picture view, and so what that means for in terms of teams working together. Sounds like there are going to be lots of great talks later on about collaboration techniques. So I'm going to talk a little bit about what's different about working in IoT and how can you work together on effective products. So just a little bit about me. I've been an IoT specialist for about 10 years now, coming from a background in UX and service design. The way I describe what I do now is product strategy, product discovery, and experience design for IoT hardware-enabled services and energy tech. And I've worked on a huge range of things from connected breast pumps to industrial power tools, via smart metering, energy management, electric vehicle smart charging, supply chain tracking, lots and lots of different things across the IoT spectrum. I wrote a book a few years ago, a fairly successful O'Reilly book about designing for IoT, and I'm going to have a couple of those to give away at the end. We're going to do that as a Twitter competition. So if you think you might be interested, get your Twitter client ready for the end of the talk, and I'll tell you what to do. So what is IoT, and why do we say that it's hard? Well, first of all, there are a few different things that kind of fall under this IoT umbrella. I'm going to talk about two of them today. The first one is connected products. This is what a lot of people first think of when we talk about IoT. Most of your conventional connected home products fall into this sort of category. So things like connected light bulbs, things like heating controllers, you know, arguably things like voice assistants. And these are things that users largely kind of interact with directly. They're quite visible. They've bought a thing, and the thing has connectivity, and the thing is, you know, that's something you use directly. There's another category of kind of product or service, I suppose, that falls into, you know, that there's actually a lot of my work tends to fall into this category. And this is what I call hardware-enabled services. An example here is electric vehicle smart charging. This is something where obviously there is hardware. In this case, there's an EV charger. The example here, there's a Tesla as well. So there's some very visible hardware involved in this. But actually, the service that's being provided, you know, those are effective, maybe third-party hardware, effectively. The service that's being provided is, you know, maybe looking at pricing signals from the electricity grid, or kind of signals about how, you know, how much demand there is, and turning charging on or off to save the customer money on their energy bill, and also to help balance out demand in the grid. So the service, the people who provide the service might not be the people who provide the hardware. Another example of that might be kind of sensor networks, where you know, the hardware is very low profile. You might have lots of sensors. You might effectively, the user interaction might be, you know, entirely via a web app or something. And these are very, very often kind of fundamentally data products. So although I'm going to be talking quite a lot about hardware today, if you do find yourselves working on a service like this, where there's data coming from hardware, or there are controls being passed down to hardware, even if you're not designing the hardware itself, there's a bunch of stuff in here that's worth being aware of. And so why do we say that this is hard? Well, I think essentially the challenge is that you're kind of bringing together, in some ways, the worst of both worlds, from hardware and software, which are quite different worlds. So in hardware, typically you're making a product. There's a bunch of money you have to spend up front to make the thing. And once you've made the thing, it's very hard to change it. So you have to get it right. And getting it right means making the right thing, but it also means for your audience, but it also means there's probably some certification that you've got to go through in terms of kind of, particular design processes and testing and stuff like that. And once you've sold that thing to people, typically that's almost the end of the relationship. So, you might have to provide them with some support if it breaks down. But largely your transaction with them is about them buying the thing. Software, as I'm sure most of you are well aware, is not like that. You can, typically companies will try and get something to market as fast as possible, learn from how people are using it, evolve it, potentially even pivot it into a different product. And then you have an ongoing kind of service relationship with your customers. It also comes with a bunch of things like information security, privacy, and interoperability challenges that you don't have to deal with if you're just making kind of a box that sits in somebody's house that never talks to anything else. So there's a whole different set of challenges on both sides. What you typically see is that companies who kind of have a legacy of doing one of these then find it quite hard to suddenly have to think about the other one. So if you've been making washing machines for 50 years, suddenly you have to think about information security. That's not necessarily a skill set that's going to be well developed in that company. So when you put these things together, there are just kind of more interdependencies, more challenges in bringing together different types of product development process, and frankly, all things that can go wrong. Okay, so just to give you kind of everything about an IoT product, I'm sort of alluding to is kind of interconnected. So there are lots of things you might not necessarily expect to shape the experience that a product offers, which will actually have an impact on it. To give you an example, if you're a designer, you might sort of overhear a conversation, this is sort of me when I started out in IoT, you might hear a conversation like, well, how frequently can we get the sensor to report data without running the battery down? And you think, okay, well, fine, that's okay. You guys work that out. I don't need to worry about that particular one. And then you find out that actually you do need to worry about that one because it makes quite a big difference to what you can do with the product. So the example here, this happens to be on the left is a gas smart meter. Obviously, there are electricity smart meters as well. What you see on the right is a couple of examples of app screens from smart meter mobile app. And if you look closely at them, you can see that they're actually different. So the electricity usage one is all about what you're using right now. The gas one, which is the equivalent screen, is sort of what's been used so far today in 30-minute blocks. And the reason for that is because gas smart meters run off a battery because you can't put mains power next to a gas pipe because that's dangerous. Whereas electricity smart meters run off a mains powered you can have a mains powered sensor, so you can get reads every few seconds. And what that means in terms of design and product is that you can, for electricity, because you've got these essentially live readings, you can show people that basically they've left something's on right now that isn't supposed to be on. Maybe you forgot to turn the oven off. If you've only got like a cumulative reading every half an hour of how much gas you used in that half hour, you can show patterns throughout the day. From those patterns, you can probably work things out. Like sometimes if you have gas heating, maybe you're leaving it on when it doesn't need to be on. But it's not the same thing. It's not the same data, and that all comes down to the power consumption. So something like that can go to the heart of what your value proposition and user experience can be. And this complexity in IoT products and service experience is a cross section of like many things outside IoT as well, of tech, design and business issues. And it's true for all kinds of digital product and service, I guess. But in IoT, it's because of the complexity, it's particularly important that all of those things are aligned to create a good outcome for users. So that's the way that I'm going to be talking about user experience today. This is not about what falls under the designer's job description necessarily. This is about all of the things that need to happen kind of across the product development, whoever's job they are, to get those bits working together. So how can we break that picture of UX down? Well, I think if you look at the kind of different experience factors as a series of layers, maybe you could sort of, in a very loose analogy, think about them as a kind of almost a bit like the tech stack, but not quite as discrete and neat and tidy. you get to something a bit like this. Now, I will say that this is a design-centric lens on the world. So we've got one blob here, which is business, and one blob here, which is tech. And obviously, if you ask business and tech people to kind of draw the landscape, you'd get a sort of a different view on that. But in terms of getting to a user experience, I think this is something what it looks like. So at the top, we've got the obvious visible things that we conventionally think of with design. So there are software UIs, might be web, there might be mobile, there might be voice. There's industrial design and hardware UIs on the thing itself. And that could be something that has a screen, it could be something that makes sound, something you squeeze, something that just blinks an LED at you, all of the wide range of things there. Then there's what I call system UX, which is the interusability, which is the experience of using all of those things at the same time, which is another kind of layer of complexity, if you like. I'm going to talk about that a little bit later. And then sort of around that, you've got the value propositions, the business models, the commercials that contribute to user experience by kind of making it feel like, by this is something I want, this is something I don't want, this is something that seems to be, a good value for the money that it costs or not. And service design, it's not just about the things the digital things you interact with. It might be that there's, there will be services running on top of that. There will be support. There might be offline things that need to happen. Perhaps someone needs to install it. And then underpinning everything is the technology and what you can actually do with that. And that will include things like, how do the things connect? What kinds of APIs do you have to get them to communicate with them, to make them work with other things? What kind of data can you collect? What can you do with that? And power consumption, which we've talked about already. So I'm going to talk about those things through sort of three different topics here. And the first one is technology, and what is it that people who perhaps are not technical, designers, for example, need to know about the tech in order to work effectively with IoT. The technical people in the audience will probably know most of this stuff, but hopefully there's some new perspectives on what that might mean for design. And the first thing that you need to get your head around is the technical architecture. What are the parts of the system? Which bit does what? Which is kind of which code runs where. If you're not thinking about this on a deep technical level, it's all right to know kind of which sort of for the user-facing functionality, which bits are coming from where. You don't have to sort of memorize the kind of the diagram, technical architecture diagram on a very deep level, but you have to have a basic sense of what bits there are, what they're doing, and how they communicate. So an example here, what you can find is that sometimes products that look like they basically do the same thing will make different decisions, and that affects the way that they work. So, for example, the LIFX light bulbs connect directly to Wi-Fi, and the Philips Hue bulbs use a low-powered network called Zigbee, talk to a hub, and then the hub connects to your Wi-Fi and out to the cloud. So, for one of the sort of key differences here is with LIFX, if you set some automation rules and say, well, I want the lights to turn on at 8 o'clock if I'm not home to make it look like my house is occupied. Those rules sit in the cloud. And then at 8 o'clock, the cloud rule kicks in and sends a message to those bulbs. For the Hue, those rules are stored in the cloud, but they also run on the hub. And so probably what's happening is 8 o'clock, the hub's kind of telling your light bulbs to turn on. Now, if your Wi-Fi happens to go down at 7:59, your LIFX bulbs are probably not going to turn on because that message is not going to be able to get through from the cloud. But your Hue bulbs probably will because the message is coming from the hub. So it's kind of a small thing in some ways, but it's quite important both actually to a user to understand that. If they have a bit of a dodgy internet connection, they might not want to buy the cloud bulbs, but also as a designer to understand sort of how things work and also how they can fail. The next thing you need to understand is about connectivity patterns, which are often related to power consumption. I talked about sensors reporting at different intervals earlier on. This is an elder care monitoring system. I'm not commenting specifically on this one. I just pulled their images. Like a lot of things, these sensors run on batteries because maintaining an open network connection uses up power. So typically your sensors are not online all the time. They wake up and report something when they report data when they see something interesting. What that means is it's often not possible to know the kind of true state of the system at any given moment because most of it's asleep. Now people buy these things initially, will sort of think, look at these things, kind of think, well, the question I really want answering is Granny okay? Actually, that's not what these kind of systems can tell you. What they can tell you is, we'll try and alert you if we see something that's not okay. In this case, you can see that there's it's identified sort of after a period of time, perhaps there was a problem. Perhaps there was a problem earlier on today. So it's still useful, but it's not quite the way necessarily that people expect it to work. And the next thing is to understand how the system could fail. I'll talk a little bit more about risk in a minute. This is a new product that's been announced. It's not out yet. You may have seen this. It's the Ring drone. It's a camera that can sort of fly around, security camera that can fly autonomously around your house. I'm a bit terrified by this, but it's also kind of cool. But you can imagine that with something like this, there are safety issues that the product team would need to think through. So if it loses power or it loses connectivity, you've got to make sure it doesn't crash into something or go haywire. So it's always an important question to ask of, like, what kinds of things could go wrong? Because when you've got lots of moving parts, there will always be something. Next thing I want to talk about is proposition. So this is about balancing the value that you provide to the user with risk, and that might be the risk of things going wrong. It might also be the risk that you might go out of business or not be able to continue to support it. So again, it's not kind of strictly design and engineering, but it's part of this interconnected picture of the product. So the first thing is understanding the user value you provide. For certain things, it's obvious. Sometimes you need to dig a little bit deeper though. So here we have, this is an example of a couple of, like, quite similar on the face of it products. Those of us who don't work in construction probably think these things would be, pretty similar. The one on the left is a nail gun. Now the value of connecting a nail gun, actually, and getting data out of it, is to help people like drywall contractors with invoicing. Because they can prove how many nails they fired, which means they can prove they've done a certain sort of square meterage of walling. So it's kind of, this was all new to me when I did some work in construction. The one on the right is an impact wrench. So this is something that tightens bolts and nuts and big nuts on buildings, and they have to be tightened to sort of quite specific level of torque so that the buildings don't fall down if there's an earthquake. And so by getting the data out of that, you can prove that all of the nuts in the building have been fitted to the right level, instead of what happens at the moment, somebody going around and kind of checking every 50th one or something. So it's better for improved safety, and it's better for kind of the checking compliance with that. The next thing is think about, well, okay, we've got the value. What could go wrong? What risks might we be introducing here with this product? Because there's always something, and they have to be in balance. You might be familiar with the Amazon, I think, is it the Echo Look? This is a camera that you're supposed to put in your bedroom that kind of helps you figure out whether your outfits work. I know I'm talking to an audience of Germans here, and I know that you're particularly cautious on privacy, for which I 100% respect. So I imagine there are probably a lot of people here who are uncomfortable about the idea of having a camera in the bedroom, shall we say. Another thing might be the risk of sort of bad algorithms being let loose in the physical world. There are lots of examples of algorithms and things that unintentionally perhaps, but genuinely discriminate against certain people. There's an example of a soap dispenser that just didn't recognize black hands. Baking that into the physical world is really quite risky. Or there's just kind of unintended danger. If you put a smart plug on a heater and then somebody kind of turns it on by accident because they thought it was on a lamp, you could burn someone's house down. So you just have to think through these things. Sometimes the risks will be worse than the value that you're creating. And then you need to think about, well, are you actually really solving the problem for people or just creating new ones? One of my pet hates when I had a child a few years ago was sleep tracking, which was a big thing at the time, because it's like, I really don't need to be told that I'm not sleeping. I want you to come and fix my problem. I want you to make my child stay asleep. There's also, I have a canary camera which does air quality monitoring, and I've had to turn it off because all it does is say, the air quality is abnormal. It doesn't tell me how, it doesn't tell me what to do about it. So it was just, it was just stressful. And then the final thing, so let's say you figured out a good product, solves a problem, it's benefits outweigh the risks. If it needs to make money for you, or it needs to pay for its service, can you support that? So when people buy hardware products, something like heating controllers, we expect them to last in our homes, 10 years or so. That's very much often not the case with connected things. So companies go out of business, or it becomes uneconomic to support the old hardware. And that becomes, it's a commercial problem, but it's a commercial problem that becomes a problem in terms of the user's experience with the product. Not to pick on Canary, but this is just a nice example. A few years ago, having sold most of their early customers a camera that promised to have certain features like cloud storage of recordings in the free version, the free tier, service tier, they then removed a load of that, upset lots of customers, and ended up having to put it back. And you can understand how that cost began to get expensive, but people don't like it when you take away things that take things away from them. So then the third thing I want to talk about is the design angle on this. And this is not about, just about the app design or kind of, what to do with hardware. This is how to think about those things working together as a system in a distributed, what I call distributed UX. And the first kind, this is kind of a parallel with technical architecture. Engineers have to think about which code, where does it make sense to have, which kind of code running. In the cloud or on a local device, for example. But designers also have to make decisions about what happens where. And there are different choices that you can make even for the same type of product. These are a pair of heating controllers. Probably some of you have got the Tado on the left. Tado, I'm not sure if this is the latest version of the hardware, but Tado's thing historically has been to put nearly all of the interactions on the phone up and to have quite minimal user interaction on the hardware. And that's quite a nice, elegant choice. It means you can add new functionality. It means you can, much more easily, and it's cheaper to produce the hardware. The Ecobee on the right, as you can see, they've made a different choice. You've basically got pretty much all of the functionality across all of the interfaces, and that's nice because it means you don't have to dig your phone out if you're to fiddle with the heating. But it also means that you're kind of somewhat constrained to the features. Once you've produced that piece of hardware, it can't change. It's very difficult to add new features onto it. Then there's consistency across different interfaces. So you might have a bunch of different devices with UIs on them that do some of the same things. How do you make those feel like a family? Consistency is always a fun one to kind of square, because it's, there are always trade-offs to make. So there will be platform conventions, Android, iOS, Alexa, those sorts of things. There'll be kind of industry standards for, things like ovens and cars. And then there's sort of consistency within your own service. So this is a Samsung oven, and you'll see that it's clearly got some of the same functionality across different, across the two, the oven UI and the phone. They have been sensible and used the same names for those features across the different devices. I have seen a number of examples where companies have not done that. Typically that happens if you've got some legacy hardware where, I talk about heating controllers a lot because that's a world I've worked in, but it's called, on one thing it's called device, it's called timer, on the other device it's called schedule, and then you have an app that doesn't necessarily have the same terminology as the device, and that's a problem for people because they don't know if those features are the same. So there's only one takeaway from this, it was just that please just use the same words. Whatever else is different, just use the same words. And then I think this is a really interesting one. This is about cross-device interactions and explicitly designing for those, not designing your UIs in a vacuum. I have a real beef about UX prototyping tools here because most of them seem to be designed to kind of make a succession of screens And they kind of lead people down that path where sometimes they don't even do flows, they just make a bunch of screens, and and it's like, it's all about the screen, brilliant, we're done. And that might be fine for, maybe fine for if you're just making an app. It's not particularly complicated, but it doesn't serve IoT very well, because what happens is someone's off here designing the hardware and someone off here designing the software, and it's a bit like if you had a movie script with two characters and you had a different writer working on each one, and every now and then they meet up for coffee and talk about the kind of thing they're doing, but you don't actually get a particularly coherent experience out of that. So it's like any interaction with a UI is a conversation. The user does something, they need to see a response. In a distributed system, that could be a 3 or more way conversation. So you do something on one device, you may see the response on another. And so for that to feel coherent, you want to think about how that works as a whole. So this is an example from slightly adapted from something I was doing recently, where I like to do concept designs as storyboards, not just kind of looking at the app, not just kind of app wireframes. So here we've got, let's say, somebody's trying to connect a microwave to a Wi-Fi network using a Bluetooth connection to the phone. That's just a pretty common pattern. So your microwave searching for the networks, and maybe it's flashing its network LED to show that it's doing Wi-Fi stuff at that point. And then it finds a bunch of networks. It tells the phone, these are the ones I can see, and it sits there waiting with an open Bluetooth connection while it's waiting for instructions. So you can see that difference here in the LED, and maybe that is or isn't the right pattern point here in terms of flashing LEDs. But the point here is that we thought through all of those things side by side. And the second thing here, I'm going to play a video. I think I've turned the sound off. So what you should see in this video, hopefully that's moving, is me with my heating controller. Sorry, more heating. So my friends call me thermostat lady now. I've done so much heating. Changing the temperature on the controller, holding up the app and waiting to see when that's, waiting to see when that changes. So right now it's telling you two different things about the state of the system. So you update one, doesn't instantly update the other one. Now there are a bunch of reasons for that, and this is a really critical thing to get right with connected products particularly. There are a number of reasons why doing something on one device isn't going to give you an instantaneous response on the other one. They are latency, it takes time to get messages across networks usually, reliability, occasionally connections go down, intermittent connectivity, which is something we talked about, particularly when you've got to be cautious with power consumption. Devices go to sleep for a while and then they wake up and go, have you got any new instructions for me? So sometimes you just have to wait a while for them to check in to get those instructions. And one thing I suspect is going on here is also the responsiveness of the cloud service. So if you've got lots of people, just as with any normal internet service, you've got lots of people trying to do stuff at the same time, it doesn't always happen immediately. And a really nice way to try and you have to try and anticipate those gaps, and usually doing something clever with animation is quite a good way to manage that, because it's very easy for the system to just look broken and unresponsive if you don't get that right. So then the last thing I'd like to talk about is effective team collaboration in IoT. I'll tell you a little bit of a story. A few years ago, I was working on some connected sockets and light switches with a startup, and I was working with a designer, sort of trying to figure out how do you allow people to talk about the various locations in their home. So rooms, or by the window, or what's that schema for describing where things are, so you can identify them. Firmware engineer was sort of sitting in the corner of the room. Wasn't anyone else around. I was like, we were kicking some ideas around, and I was like, let's just ask Ivan what he thinks, just for another opinion. And Ivan, the firmware engineer, said, oh yeah, I was just baking that into the firmware for the plugs. So he'd come up with his own one and was just about to kind of bake that into code. So we had that conversation at exactly the right time, because it meant that we could all collaborate and come up with what we thought was the best thing. Had we not thought to talk to Ivan for another 2 weeks, it would have been really hard. He would have gone ahead, done his own thing, and it might have been really good, but it would, we would have probably been stuck with it. So point here is that user experience issues can be kind of baked into all sorts of places. So to get a good result from that, the team knowing when to talk to each other is critical. It takes lots of different skill sets to make a good IoT product, and it's just not feasible for any one person to know all of it. But if you all understand what everyone else on the team is doing well enough to understand when this looks like a problem that this person might need to be involved in, that's a good place to be. So how can you create that? I'm really interested to see what comes out of the talks later on today. I'm sure there'll be lots of great content about facilitating collaboration. In my view, I think the first, this is pretty obvious. The starting point is that everyone needs to know how what they're doing fits with user goals, product goals, organizational goals, and at least then you've got kind of a shared vision. You need to incentivize people to collaborate and share, not just do their thing and hand it over. If you only measure engineers on delivering story points per sprint, or designers on how many screens they've made, you're not you can't blame them if they are not able to make time to collaborate with people. So you might say, well, our stories have a definition of done that includes, we've had a design session on this, for example. So you have a whole team weekly meeting. I've seen this work super well, particularly kind of medium-sized teams. What is everyone working on? What kinds of issues are you thinking about? You'll find that this is where you learn, for example, that firmware engineers spend an awful lot of time thinking about power management. Can people do demos? Great if they can. If they're not ready, what kinds of questions do they have? And that just helps everyone get a sense of what the different, how the different skill sets work, and what is a question for who, kind of thing. And then the last one I suggest is to work through key use cases as a team. I've got an example here. You probably can't read the details on here, and that's okay. This is a tool I've adapted from service design. It's called the Blueprint. In service design, the intention is to show what are the things the stages the user moves through, and the interactions that they have with the service, and what's required kind of back office, sort of behind the scenes, if you like, to make that happen. So along the top, you can only see one of them here because it's a partial diagram. The top line is basically like what stage in that process are we at. In this case, we mapped that to states in a state diagram elsewhere. The top two green lines, so what are the user interactions, and then what are the on-stage actions that they see from the app and from the device. This was a kind of a sort of two interface system. So everything above that, everything those green bits, that's what user can see. Underneath, we've got backstage actions broken down from the app, from the device, and from the cloud. So, for example, when user turns on the device, it powers up, and then they see an LED flashing because the power's coming on. It's that kind of stuff. Later on, when they get the device, they use Bluetooth to connect to the device, get it onto Wi-Fi. Then it starts talking to the cloud, and then the cloud has to verify kind of that this device is a genuine device from whichever company. So what you've got here is not just the user experience bits, but on a very conceptual level, kind of some of the technical enablers that are happening. And so this allows your designers to work to produce something that's grounded in kind of good understanding of the technology. It also understands and helps the engineers think through what do we need, first of all, what's feasible, help the designers understand what's feasible, but secondly, how might we be able to do this? I've just found that a useful tool. As an individual, what can you do? I mean, this is going to sound probably sound a little obvious, but start by being curious, be interested in what other people of different skill sets are doing, be respectful. Don't pigeonhole them. Go, oh well, you're this person, so you're in this role, so you don't need to know about this. No one can know everything, but good ideas and good suggestions can come from anywhere. And sometimes unexpected people will make those connections that result in a really nice idea. Be prepared to think up new ways to explore problems. So conventional software tools, I've talked about UX prototyping in particular, they may not be very well cut out for some of the thinking you need to do for IoT. And learn how to communicate what you're doing to people outside your specialism, and make the effort to understand the way that they communicate. So from my advice, I guess, to designers and engineers, and I've talked to engineers to make sure that this is, to hope to try to get this right as well, hear the other perspective. For designers, I think the important starter really is to kind of learn to ask the technical questions that shape the user experience. So the things I've talked about: what's the architecture, what are the parts, which bits are happening where, how do they communicate and connect, how quickly and reliably can you get data or messages around the system, what things could go wrong, that kind of stuff. And for engineers, it's how can you help the designers think through, who don't have your technical understanding, think through the art of the possible. So what's the technical context? What kind of constraints are you facing? What kind of trade-offs might you have to make? So you say, well, I know you want this number accurately every 5 minutes, but that's going to cost a lot of money. We could do a trend showing changes over time. Does that give you the same, when that's really cheap to do, does that give you the same benefit? Explaining conceptually how things work to non-technical people, is an extremely useful skill. And I think helping people understand complex system effects. So what a designer might think is a really low impact change on the front end might have quite a big impact across multiple components on the back end. And I think just having that understanding that there are lots of things that shape UX, and they're not necessarily the things that might be your design. Always, all of them fall into the designer's job description. So it's not just about people making app UIs, although it may bubble up to that level. So that was the end of that. I look forward to your questions. Just wanted to talk about the competition. So if you would like a copy of the book, I've got two. I could probably wangle a third, and they could either be print or digital copies. Please tweet Thoughtworks at Thoughtworks_DE with "I want a book" and the conference hashtag. And the people who are fastest, the two, I could push it to 3 people who are fastest, will get in touch with you to get your details to send you a book. Thank you.
Thank you, Claire. That was really, really inspiring. I loved the nice contrasting checklist at the end, showing what each of the roles can do to build that bridge for collaboration. And we've had someone who was already fast in writing a question to you. So maybe I'll read that out, and we'll see what you think about it. So the question is, how can interusability be applied in practice in IoT UX design? How can composition, consistency, continuity principles practically be applied or used during the design process?
There's a paper citation I need to give you, actually, which I've realised is not in those slides. So I'm going to add that. I'm going to add that in. I did not come up with the concept of interusability. There's a so I'm going to tweet that paper citation afterwards. And the fact that you've picked up on this person's picked up on those 3 terms suggests to me that they've heard it before. So how can you apply it in practice? I think it's really about thinking. Essentially, it's kind of a checklist. I mean, I very consciously use those things when I'm doing design work or requirements kind of work. And I think you start with composition, definitely, because those are decisions that get made much earlier in the process. So this is one of the first questions to ask. I worked on a really lovely project for a company called LV. It was make a connected breast pump. I won't tell you why I won't go into why that's a brilliant idea, but trust me, it's a much better idea than it might. Than your first reaction might be, why would you do that? But actually, it's a brilliant idea. And they had realized, the point that I was working with them, they'd realized that in order to figure out what controls needed to be on the hardware, that was their critical path. They then needed to understand what controls you would have in the app. What, you know, even if you didn't have a finished app design, what's that interaction? What does that interaction model look like? And so we went through a prototyping process to figure out, if you've got one pump, you might be using one pump, or you might be using two pumps, and then the things have to kind of sync with each other. You know, or actually you just want to stop one and change the bottle kind of thing. And then you've got the app, and how does this sort of three-way conversation work? And that was very much about, well, you know, you start probably from the extremes of, we'll put all of the functionality on each one, or we'll put none of the functionality on the hardware. But then you get to, and you know, and those are kind of those are sort of your extreme points, but actually you'll end up somewhere in the middle. And so it's a real kind of trade-off, and it involves things like hardware costs and as well as user experience. And then when you get to the kind of, when you get to consistency and continuity, that's more about, well, consistency is more about design craft, essentially. You know, how will you make these, we know what's in these UIs, how will you make them feel like a family? So that sort of comes in a bit later on, probably. The continuity one is really interesting though, because that starts from, how will these things connect? How quickly can we get things? Can you make this thing more responsive? Okay, we've got a problem here. This is going to be quite slow. Can we make this thing more responsive, you know, at reasonable cost? Or are we going to have to find ways to deal with that, deal with those delays in the UI? So I think it's kind of, they're all important, but they kind of, it's understanding where those things fit into product development, I think, and just being aware of them. And once you know, I don't have a formal process for doing those things. I would say that the prototyping stuff side by side is immensely helpful for thinking through all of those. But yeah, that's what I'd recommend. It's just getting into a mindset as much as anything.
Super, thank you, Claire. The next one is also really interesting, thinking about IoT devices that are connected to humans, like for example. So how do you design interaction and movement of the human? Yeah, that's a question. How do you design for interaction and movement of the human?
Wow, that's a really interesting one. I confess I've done less work with wearables, certainly things that are measuring, you know, kind of more about sort of data, and it's been more about the data in terms of those things. But I think there are obviously there are a bunch of interesting industrial design concerns about things being comfortable to wear, and you know, and just kind of appropriate for the context of use. And then what else? So there's, I guess it's a lot of it's about the data and what you can do with it, and what is too much, and how accurate is it. And yeah, I guess there's another area. So that's your whole kind of the you know, the Apple Watch that can detect atrial fibrillation. You've got to be so careful. I mean, it sounds like they've got it right and it's accurate, but you can't mislead people if you're trying to tell them things about their body. I worked a little bit on you know, on the continuous glucose meters for diabetes. You know, these things have to be, obviously if it's medical, there's a whole bunch of regulation around that, but these things have to be, you have to be certain that they're measuring what they're measuring. And then there's and I kind of read this into the question. Then there's kind of using that sensing actually as an interaction medium. So, you know, gestures. If you could, you know, you've got a TV in front, you know, if you're looking at the TV and trying to decide what to watch, and you could just kind of raise your arm up and go like that to swipe through things. That's a really interesting one. I'm not that kind of interaction designer, I'm afraid. But it's yeah. So I don't know if I've answered it, but there's kind of a, you know, within that question, I think there are a number of areas that are all pretty interesting.
Lovely. And the next, thank you, Claire, for answering all the questions we're poking at you. I think we probably have maybe time for one, maybe two. The next one here is, has the recent shift to more remote working had a negative effect on team collaboration? Has this affected prototyping the hardware and software together? And how have you addressed this?
That's a really interesting one. So since we all went remote, I've been working on a couple of projects, and I've been very fortunate. My personal experience, I've been very fortunate that both of those projects were for organisations that had quite a lot of remote working anyway. It was a fairly easy shift to go from one thing to another. Also what actually I talk about hardware, but a large part of what I do is kind of maybe one step removed from the hardware. So I've recently been working on something where I was specifying hardware interactions, but it was for it's for an operating system that would have to support a huge range of devices. So there was no physical. Actually, there's a Raspberry Pi. Where's my Raspberry? There might have been a Raspberry Pi, or there might have been it could be something that also ran on a kitchen appliance, for example. But we weren't working with a piece of hardware. So for me, it's really been, for me personally, it's been a good opportunity to get more into things like Miro. So that blueprint I showed you, that's made in Miro. I'm a new, other whiteboarding tools are available, but I'm getting much more dependent on whiteboarding, digital whiteboards. I think that's actually a really great tool. So what I have heard from talking to people I know is that for companies who are in the throes of producing hardware, it's been really quite challenging, because you have to take those workshops and labs and put them in people's homes. I hear that I was talking to a former client of mine recently, and that they said they've done that, and actually it's been quite successful. They had very, very good product development processes anyway. So if anyone was going to pull it off, I think they would have done. But yeah, clearly if you're working on big industrial robots in a lab, that's which is the other end of IoT. That's challenging. But I think the theoretical work, the kind of service design type work, the sort of the interaction thinking, and and obviously the software development, clearly that's quite that translates pretty well to remote.
And I think we have 1 minute, so I'll throw one more question at you, Claire, if I may. And this one is around incentives for engineers to collaborate. The question is, what kind of yummy jelly beans do you have in mind? Is open source, is the open source mindset beneficial? Question mark.
Oh, okay. I don't pretend to be an engineer or to know what's good for engineers. And I won't. So please shoot me if I say the wrong thing. I don't know. I do think that one thing I've seen is, I think this isn't just about engineers. This is about everyone. Everyone likes to have a degree of autonomy over how they do what they do. Nobody likes to be measured on how many widgets you've delivered, and only on how many widgets you've delivered. So I think, and I have seen that, and I think some of my experiences around, where I'm trying to figure out what to make, but I'm having a hard time kind of finding somebody that can have those conversations, that can help me understand what's technically possible in that context. It's not because they're not smart people who can't think like that. It's because everyone's under the cosh to deliver X number of story points, and the story points are this, that you will press, somebody presses this button and this thing happens, So it's kind of, I think it benefits the whole team when people are incentivized in ways that give them autonomy and give them some freedom, and scope to do that kind of a little bit, participate in more of that exploratory work. It might not be what everyone wants to do, but so I haven't really answered the question. But obviously for some people that might be having work they can publish on GitHub and go, look, hey, I did this, and recognition. I don't know what the rest of those levers would be, and I look forward to hearing from the audience what they might value.
Wonderful. Thank you, Claire. And maybe we can take that conversation on incentives to Twitter and exchange a few more ideas. I would also
Absolutely.
be really curious to hear more of what has worked for
Yeah.
people. So I think, Claire, I would say thank you very, very much. It was really inspiring to hear your talk and all the different tips for designers and developers of what we can do to understand the other a little bit more. And I would say thank you to you. And I'll be looking to welcome now our next two speakers.